Video number 3 to the Geometry Spring Final Review. Let's get going. Okay, in this section we're finding area and we're finding perimeter of the following figures. So some of these problems we don't have a lot of space to write, but I think we'll be okay. So first of all, we need to know our formula for area of a circle, and that is pi times radius squared. And 13 is all the way across, so that is the diameter. So the radius would be half of that, so the radius would be half of 13, which is 6.5. So the area is going to be pi times 6.5 squared. So all I'm going to do is put 6.5 squared into the calculator and get 42.25 and attach the pi back behind it. So it's 42.25 pi. And this is in feet, if we want to label. Oh, feet squared, sorry. Now, if you don't want your answer in terms of pi, then you can just put 6.5 squared times pi in your calculator, and then you can get the decimal approximation for the area. Okay, circumference. We need to know this formula. Circumference, remember, is the same word as perimeter. It's just the special word we use for circles. So circumference, you can either use 2 pi r or you can use pi d. I like pi d the best anyway. And we know that the diameter is 13, so pi times 13 is simply 13 pi. And circumference, like perimeter, is measured in feet, inches, meters. No units squared, no units cubed. Okay, second picture. I can tell this is an equilateral triangle because all 3 sides are congruent. I'm going to start with perimeter because perimeter is going to be the easiest. So if I want to know the perimeter, then I just add the 3 sides. So 8 plus 8 plus 8, or 8 times 3, and the perimeter would be 24, and then that would be inches. Okay, if I want to find area of a triangle, that's when I do base times height divided by 2. So this right here is going to be the base of my triangle. Do you know how long that is? Yep, it's 8. And then we need to figure out the height and divide by 2. The problem is we don't know the height. Height has to be straight up and down and perpendicular to the base. So I'm going to drop down this altitude, form a 90-degree angle with the base. Remember, if it's an equilateral triangle and all the sides are the same length, then all the angles are the same measure. So this is a 60-degree angle, this is a 60-degree angle, so is this one, but it's split in half, so it's a 30, 60, 90 triangle. Okay, so I know that this side is 8, across from the 30, that's x, across from the 60, that's x square root of 3, and across from the 90, that's 2x. So if I solve this equation for x, what would I get? 4. So this little piece from here to here is 4, which I imagine most of you knew. And then the height is x square root of 3. So if x is 4, then the height is 4 square root of 3. Okay, I'm going to keep this in simplest radical form. And so I do that by simply taking 8 times 4. I just ignore that square root of 3. I take 8 times 4 and divide by 2. And then I attach the square root of 3 back behind it. So this is 16 square root of 3. And because it's area, that would be units squared, so inches squared. And that's the area of our triangle. 16 square root of 3 inches squared. Now, if you wanted a decimal, then you could simply go 8 times 4 square root of 3, get that answer, and then divide by 2, and you can get your decimal approximation. And then let's just see if that's the same thing as the 16 square root of 3 that we found. And it is. Same answer. Okay, next picture. I can tell that this is a square because all 4 sides are congruent. You don't see the 90-degree angles, so I guess it could be a rhombus. But either way, it doesn't really matter. I'm going to find the area by taking length times width or base times height. And so if I take length times width, then my length and my width are the same. So 12.3 times 12.3. Actually, it does matter that if this was a rhombus, we would actually find the area different. I apologize for that statement a minute ago. So I really should see 90-degree angles in here to know that this is a square, because if that happened to be a rhombus, I would use a different formula for finding area. So we're going to assume that those are 90-degree angles, even though they weren't marked. So let's take 12.3 times 12.3, and we get 151.29. And if it wanted us to round to the tenths or something like that, then I could say 151.3. So there's our area. Okay, perimeter is very simple. Perimeter is the distance around. So it's 12.3 plus 12.3 plus 12.3 plus 12.3. Or you could simply take 12.3 times 4. And if we do that, I'm not going to show you, but you get 49.2. And perimeter, once again, is just centimeters. Okay, first three shapes, not too bad. The triangle took a little bit of work, but that's not too bad. All right, next shape. Do you know what this is? This is a trapezoid. And so to find the area, I take height times base 1 plus base 2 all over 2. So do we know the bases? Yes, the bases are the parallel sides, so the bases are the 12 and the 18. So I'm going to put 12 plus 18 in the parentheses. I'm going to recopy the all over 2. My problem is I need to find my height. So I'm going to drop down this little segment right here called an altitude. That's the height. This guy over here would be the height as well. So I need to know this segment here. Height is perpendicular to the base, and it forms a 90 degree, it's perpendicular to the base, and it connects the bases together. Okay, if from here to here is 12, then from here to here is 12. Well, if the whole thing is 18, then what's this little piece and this little piece? They're each a 3. That's because I take 18 minus the 12, which is 6, and then if these add to be the 6 and they're the same, then they're each a 3. Okay, so if this is 3 and this is 5, do you know what this is? It's 4. This is a 3, 4, 5 triangle. Now, if you didn't know that, you'd have to go and use Pythagorean theorem. You'd go x squared plus 3 squared is 5 squared, but you get your 4 that way. Okay, there's so many different ways to work this out. So I'm just going to go 4 times 12 plus 18, get that answer, divide by 2. But I could do this lots of ways. So my area is 60 inches squared. Okay, perimeter is the distance around the shape. And if this piece is 5, so is this piece here, because they show the little tick marks, so those sides are congruent, which makes this an isosceles trapezoid. So if I want to know the perimeter, then I add 12 plus 5 plus 18 plus 5. So I'm going to add the 12 plus 5 plus 18 plus 5. And if I do all that, I get the perimeter to be 40 inches. Okay, our next one. Let's count the sides. 1, 2, 3, 4, 5, 6. We've got 6 sides, so this is a regular hexagon. And we have a formula for finding the area of regular polygons, and that is 1/2 AP. So let's just find the perimeter really quick, because that's going to be really easy. If I want to find the perimeter, I add up all the sides. Well, all the sides are the same, so 1 plus 1 plus 1 plus 1 plus 1 plus 1, or 1 times 6 gives me 6. So my perimeter is 6 centimeters. So right now, I could actually put that in my area formula. 1/2 times the apothem, got to figure that out, times the perimeter. Well, we just found the perimeter to be 6, so I'm going to go ahead and plug that in. I just now need to find that little apothem. Okay, I'm going to draw down the apothem. Remember, it goes from center of shape to middle of side. I'm going to draw in the radius. It goes from center of shape to vertex. This right here, do you know how long that is? 0.5. If the whole side is 1, then this is half of that, so this is 0.5. Okay, now I need to know what angle that is. So this is where you take 360 and you divide by the number of sides, which is 6. When you do that, you get 60. So the central angle, which is all of this right here, is 60 degrees. Well, the apothem splits that central angle in half, so that means that this is a 30-degree angle. So this angle right here is always half of the central angle. So if that one's 30 and this one's 90, this is our 60. So across from our 30, that's our x. So 0.5 right there, that's our x. Across from our 60, that's x square root of 3. And that's what I want. That's the apothem. I don't even care about the radius. So if x is 0.5, then the apothem would be 0.5 square root of 3. Okay, first I'm going to keep this in simplest radical form. So in order to keep it in simplest radical form, I'm going to ignore the square root of 3. And I'm going to take the 1/2 times the 0.5 times the 6, and then attach the square root of 3 back behind it. So 1.5 square root of 3. And that would be centimeters squared. If I did not want to keep it in simplest radical form, I just wanted a decimal, then I could do 1/2 times 0.5 square root of 3 times 6. And there would be my decimal approximation. So about 2.6. So I'll go ahead and write that. About 2.6. Okay. Circles. All this stuff we learned about circles. Got some vocabulary match up here. So let's look. AC, it goes through the center of the circle. Both endpoints are on the circle, so that makes this one a diameter. Okay, number 2 is line CD. Line CD is all of this. It cuts through the circle, so we call that one a secant. Okay, this next one is segment AD. So segment AD has both endpoints on the circle. It does not go through the center of the circle, so we simply call that one a chord. Okay, number 4 is angle AOB. Angle AOB, this angle right here. Since its vertex is at the center of the circle, we call that one a central angle. Okay, the next one is angle CAD. Angle CAD. This angle has its vertex on the circle. So when the vertex is on the circle, that is called an inscribed angle. Okay, number 6, this is an arc. So it wants arc ADC. ADC, that's half of a circle, so we call that a semicircle. Okay, number 7, this is ray AE. So it starts at A, it goes to E. This right here just touches the circle once. Even if I extended it and made it a full line, it would only touch the circle once. So we call that one a tangent. Okay, the next one is an arc, arc BC. So this is a minor arc. It's less than halfway around. Remember, when you name a minor arc, you only use 2 letters anyway. Okay, the next one is segment OA. Segment OA starts at the middle of the circle and touches the circle, so that is called a radius. And then the last one is an arc, arc B all the way to D, all the way to C. That's more than halfway around the circle, so we call that one a major arc. Remembering all those fun words? Oh yeah. Okay, next page. All right, we have some formulas that we need to remember. But don't worry, if you don't remember these formulas, we have made you a formula sheet to use, and it's got the formulas on there that you need. Okay, this is a tangent because it touches the circle once. This is a tangent because it touches the circle once. When 2 tangents meet, if I can make my hands do it, if 2 tangents meet at an exterior point, then those 2 tangents are congruent to each other. So 62 equals 7x minus 8. And then all I have to do is solve it. So first I'm going to move my minus 8 by adding 8 to both sides. The 7x drops, 62 plus 8 is 70, and if I divide by 7, I get 10. So there's my first one. That one was pretty simple. Okay, these next 3 have to do with the in, on, out formulas that we learned about. And most of you were pretty good at this at the time. So here's our angle, and this is the vertex of the angle. Would you say the vertex is at the center of the circle, in, on, or out of the circle? It's out of the circle. So when the vertex of the angle is out of the circle, the formula for finding the angle is half of the big arc minus the little arc. Okay, so 1/2 big arc minus little arc. So do you know which one's the big arc? The big arc is the x, and then we subtract the little arc, and the little arc is the 30. And then which one's the angle? The angle is the 45. So the 45 goes right here. Now I could solve this different ways. I could distribute the 1/2, or I could get rid of the 1/2 by multiplying by 2. If you ever want to get rid of a fraction, you multiply by the reciprocal. And then this makes 2 over 2, and 2 over 2 is 1, so that's gone. All you're left with is x minus 30 on the right side, and 2 times 45, that's 90 on the left side. And then from here to get x by itself, all you have to do is move the minus 30. So you add 30 to both sides, and if you do that, you get x is 120. Hopefully you remember this. It was a little while ago, but hopefully not too long ago. Okay, next one. This angle's vertex that we see right here, would you say that it is at the center of the circle, in the circle, on the circle, or out of the circle? It's in the circle. So our formula for finding the angle is half of arc plus arc. Okay, which one's the angle? 55 degrees, that's the angle. Recopy the equals 1/2, and now I want to add the arcs. So one of the arcs is the x, plus the other arc is the 80. Okay, once again, I could distribute the 1/2, but I'm going to get rid of the 1/2 by multiplying by the reciprocal. So I multiply this side by 2 over 1, so then I multiply this side by 2. The 2's and 1's cancel, shoop, shoop. All you're left with is x plus 80 on the right. And then how much is 2 times 55? 110. And then to get rid of that 80, we're going to subtract 80 from both sides. And if you take 80 away from 110, you get x to be 30. And there's that guy. Okay, next one. Our angle, let's look at its vertex. Its vertex is right here. Would you say that the vertex of the angle is at the center of the circle, in the circle, on the circle, or out of the circle? It is on the circle. So when the vertex is on the circle, we find the angle by taking half of the arc. Okay, so which one's the angle? 4x minus 5, that's the angle. So 4x minus 5 equals 1/2, and then half of, what's the arc? The arc is in between the angle, remember, and the arc is 130. Okay, instead of multiplying both sides by 2 this time, I'm just going to take half of 130, because that's easy. What's half of 130? 65. And then just drop down the 4x minus 5, and then let's just solve this equation. To get rid of the minus 5, we would add 5 to both sides. The 4x would drop. The equals 65 plus 5 is 70. And then if you divide both sides by 4, we get 17.5. And that's our answer to this one. Okay, I know we've been doing this for a while, but instead of stopping and making a fourth video, let's just keep going. All right, next one. Cody helps his father feed the livestock. Yesterday they fed a calf a cake of feed that was shaped like the square prism below. What is the total surface area of the cake of feed? Okay, if this is a square prism, then that means that this base here is a square, so all sides are 5. And I want to know the total surface area of this. Well, this is a prism, so I'm going to go to prism, and I'm going to look for the total surface area formula. And our total surface area formula is pH plus 2 capital B. Now, you've got these formulas also on your little formula chart we're giving you, so don't worry about that. Okay, capital P stands for perimeter of the base. So I'm going to call this guy right here the base. So what would the perimeter of this base be? 5 plus 5 plus 5 plus 5, 20. Now, this H wants the height of the prism. So if you stood this prism up on its square bottom, how tall would it stand? 12 is how tall it would stand. And then plus 2. And then capital B stands for the area of the base. Well, what's the area of this base? Length times width, 5 times 5, it's 25. Okay, and then I just work all that out, and you get 290. And surface area is always in square units. Okay, we've got one more page left. One more page. Next one. The main entrance to the Louvre Art Museum in Paris is shaped like a pyramid. The pyramid is 61 feet tall and has a slant height of approximately 81 feet. Each side of the square base measures 120 feet. What is the lateral surface area of the pyramid? Well, let's just get our formula. So I'm going to go to pyramid. It wants lateral surface area, which is 1/2 capital P L. So the lateral surface area is 1/2 capital P L. And then I need a couple other things here. It says each side of the square base is 120. So that's 120, that's 120, that one's 120, that one's 120. Okay, so this capital P here, it wants the perimeter of the base. So if every side of the base is 120, what would the perimeter of that base be? 120 plus 120 plus 120 plus 120, or 120 times 4? 480. And then this lowercase cursive L wants the slant height. Well, they told us in the reading. They said the slant height is 81. So I would just take 480 times 81, divide by 2. And if you do that, you get 19,440. Once again, this is surface area, so that's square feet. Okay, next one. It wants the volume of the shape. So what shape is that? It's a cone. Okay, so let's look at our cone. And the formula for volume of a cone is 1/3 capital BH, but I can use this one right here, 1/3 pi r squared h. So volume is 1/3 pi r squared h. And we need to know the radius, so 1/3 pi. And then what's our radius? Well, the radius would be 6. Because 12 is all the way across, that would be the diameter, so the radius is half that. It's a 6. Don't forget to square it. And then how tall is the cone, do we know? We do. The cone is 15. That is the height of the cone. It's straight up and down. It starts at the vertex and drops to the middle of the base. Okay, I'm going to keep this in terms of pi. So I'm going to ignore the pi. I'm going to take 6 and square it, multiply it times 15. And then, instead of multiplying by 1/3, I'm going to divide by 3. And then that's my answer, just with a pi behind it. So my answer is 180 pi. And if you didn't want your answer in terms of pi, then you could put 180 pi in the calculator, and you could have your decimal approximation, which is about 565.5. Now, volume is feet cubed. Volume is cubic units. Okay, next one. I want the volume of this shape as well. So what shape is this? This is a pyramid. When the shape goes up to a tippy top and all the sides are triangles, then that's a pyramid. So all the sides are triangles, the bottom is a square, so this is called a square pyramid. So I want the volume of a square pyramid. So I go to pyramid, and this is my formula for volume of a pyramid. So volume is 1/3 capital BH. Okay, capital B wants the area of the base. Well, my base is this square down here. So what would the area of that square be? 36. 6 times 6 is 36. Okay, and then H is the height. And do we know the height? We do. The height is this 13. It starts at the vertex. It drops down to the center of the base, and it is straight up and down, so that's the height that we want. Okay, so I could do two things. I'm going to show you two things. I could type it just like I have it, 1/3 times 36 times 13. That's one way of getting the answer. Or I could take 36 times 13 and divide by 3. That's another way of getting the answer. Either way, you get the same thing, 156. And remember, volume is in cubic units, so that would be inches cubed. Okay, last one. I make you work a little bit harder on this one, but it's not too bad. Okay, this shape, my students had a hard time knowing what it is. Do you know what shape this is? This is a prism. It does not go together at a top point like this one, so it's definitely not a pyramid. Plus, the sides are rectangles. When the sides are rectangles, you're talking about a prism. And then a prism has two parallel bases. Well, the bases are these triangles. So this is called a triangular prism. That's what this guy is a triangular prism. Okay, because it wants volume, I'm going to go to the prism section, and I'm going to look up volume, and volume is capital BH. Remember, capital B stands for area of the base. So I need to find the area of this base. I have to find the area of this triangle. So I got to work on that. So remember, to find area of a triangle, we take base times height divided by 2. So this is the base of my triangle. How long is that? 10. Now I need to find the height of my triangle. So let's talk about the height of the triangle. The height of the triangle would be this piece right here. And it's going to cut that base in half. So how long is that? 5. How long do we know this piece is? 15. And I'm looking for this guy right here. So what could we do? I don't know that it's a 30, 60, 90. I don't know that it's a 45, 45, 90. So I could just stop and do Pythagorean theorem. I'm going to call that x. So it would go x squared plus 5 squared is 15 squared. Okay, I'm going to show my work on the calculator. So I'm going to take the 15 squared, subtract the 5 squared, because I got to get x by itself, and then I'm going to square root my answer. And I get about 14.14. I could round to the tenths. I'm just going to round to hundreds. So let's say 14.14. And that is the height of my triangle. 14.14 is the height of my triangle. So that goes right here. Okay, so let's figure this out. So I'm going to take 10 times 14.14, get that answer, divide by 2. And there's the area of my triangle. 70.7. So that goes right there in capital B. Okay, now I need to know the height of the prism. This does not want the height of the triangle. I know my students thought that a lot when we were working these problems, but the height of the triangle I needed when I was finding the area of the triangle. This H wants the height of the prism. If you stood this prism up on its triangular bottom, how tall would it stand? This is how tall it would stand, which is 20. So all I have to do is take 70.7 times 20, and if I do that, I'm not going to show you, you get 1414 meters cubed. And that's it. Good luck. I wish you all the best on your final exam. Thank you.